monitoring and rollback if need be.
So generally speaking, it sounds like you're pushing the responsibility almost completely, including the product management, the operational side, onto developers. Is that right? And
It's
that's
in some way, yeah. Well, it's not. We're not replacing everyone. It's not like we say the developer does everything and no, and we don't need anyone else.
Mhm.
We have operations, we have product, we have an architecture team, but the tasks that we're doing are different. The the product, the way the product work changes. Product are responsible. Of course, there's a lot of work for the traditional product has to do to understand the concept of what you want to build, how it's going to look for customers, talk with customers, get feedback, compile from that feedback different features, different ideas, different stuff. But then traditional product writes a document, a very long document, and then gives that to a guy from development and saying, let's build that. Instead of doing that, the way is sit together with someone from development, explain what we want to do, maybe write a document just so that a minimal document that will remember all the stuff. But the question that you're going to get from development is going to be, okay, how can we have something up and running in 2 days? Some feature, something to check it. Check the ideas sound, try to do the minimal feature, then to enhance it with additional feature, to additional stuff. How can we make it in iterations instead of doing a big project of big something? Let's try to do it in very small iterations and push the iterations as fast as you can, one by one, and then check each iteration how it's doing. Of course, obviously you can't do that all the time, but you can do lot of the stuff. You can, for instance, use a feature toggle. You can start adding features, open them, put them on production, open those features just to a few users, product, maybe some other guys, QA, check those features as you develop more and more features in that new project. And that code is already running in production, so there's no problem of opening it to other users. It just toggle, decide which users you open it. And of course, there are cases when you build all new products and then you need to figure out how to do that. So the first thing you want to do with new product is get it online in production, even doing nothing. And then start. You won't open it to all users. You open it just to a few selected users that you're going to work with, that you're going to test with. But once you solve the deployment problem, the feature toggling problem, and start adding more and more features, one thing you see is that's happening is that your product line that we started with, that had an idea and thought to write a 20 pages document, by the time to reach the fifth, and he sees something already working, it decides he wants to do something different. Because he sees something working. He gets the notion of, oh, it looks like that. Oh, so maybe we can do it this way. He gets new ideas. And so the product evolution also becomes in a continuous delivery kind of style. You evolve the product. You evolve with what you have, and you release features very fast. You can actually test stuff. You have an idea. So we've seen cases where you have an idea in the morning. The next day it's in production, and you test it. You do A/B test, decide whether you want to have it or not. Then maybe drop it, maybe continue with it. Why not do it? Why not do something like that? It sounds crazy to have an idea today, A/B test it in the afternoon, and drop it in the evening. But why not if you can?
And how does the developers cope with it? I mean, is that a big cultural change from what people are used to, or is that?
It's a huge cultural change. I think one of the main changes is that people learn to use TDD, test-driven development. I think most of the developers we have today, before they came to Wix, everyone knows JUnit. Every developer in Java knows JUnit. Everybody wrote few tests. No one ever that I've seen in Israel, almost no one has done TDD. And TDD is not writing. It's advertised as writing the test before writing the code. That's not exactly what it is. It's from my opinion. TDD is writing enough tests during writing your code such that you're confident that your code is running. And such that you're confident that if you're going to deploy that code to production, it's going to work. And so I think today in Wix we have a few thousand tests of unit tests, and run very fast after every time someone checks in code, those unit tests are going to run. And if something broke something, we know that in a few minutes, and that gives you the confidence to not be afraid. One of the huge culture changes that you see. There is some processes we see every developer goes through. First thing, why do you have to write tests? It will take more time to develop. And then it's nice, but still, you're crazy to get to release that. You can't do that change release today. It's never going to work. And then you come to a point where, I can actually change this line of code and deploy it, and I'm not afraid because I have all of those tests that guard that I'm okay. And you actually get to a point where, I had a developer that come to me and tell you, why don't we deploy that? We know we can. You can do whatever change you want, and then we'll deploy it. It's okay. If the test pass, we're okay. And it's a huge change in the way we think. Instead of thinking about, I don't want to touch it. It works. So I don't want to touch it because I don't know what's going to break. You get to a point, do whatever you want with it. It's okay. Break it. You know what? Delete it, write something different. As long as my tests are working, I'm fine. I have no problem with that. It's a huge change. And people that start working, that actually work this way, can't go back. There's actually no going back from that.
Yeah. I think it's also good on an educational level, right? So, for example, what we do here in Gigaspaces is a test is a great way to study someone else's code, right? Because when you look at the test, you actually...
Test or documentation. You ever heard
that? Yeah, sure, of course. But I mean, in the test, what you can do is you can actually look at what the guy meant for the code to do. So it's also a good way to actually communicate between team members.
Another thing, there is a notion called learning tests. And that's when you have a third party, you don't really know how to use that. You create tests that use that third party the way you think you're going to use that third party. And you're going to leave those tests as part of your project. So you have a reference of how to use that third-party library. You don't really check anything of your code, but you check that your assumption on what this third-party library does are sound. You don't have to do that, of course. It's called learning, because if you know how to use that library, you won't do that, of course. But you can say that anytime that a traditional developer would create a main and try something, write a test. Also, there's a lot to talk about how to write tests, what are effective tests and stuff like that.
Sure,
that's different topic.
That's another topic.
Now, time check. We're already, I think, in 15 minutes or something, right? And that's where we are right now, which is pretty long.
50, yeah.
Yeah. So let's give it last 5 minutes, and maybe we could skip the rest of the question because I think we touched the core of things. I think that the most interesting part is how you run the operation, how you do the continuous development, and all those stuff is very intriguing in my view. Like in this last 5 minutes, maybe you could elaborate like how much you're satisfied from what you have and what do you expect to do, what do you plan to do next to even improve it better?
Well, I think what we've done so far is we've done a lot of improvement. We're already at a point that instead of being afraid of doing deployments and doing releases, we're doing them very easily in our Java and C code, which is one of our server sides. We still have issues with getting the same confidence and same development velocity in our HTML, JavaScript, and Flash areas. And that's simply because testing tools are not as mature in those areas as they are with Java, and testing is not as easy. We actually did create a few testing utilities, testing solutions for JavaScript that we're going to share at some point. It's on the roadmap, but we'll do it soon. And so that's one thing we want to improve. Another thing that we want to improve is the velocity of our releases. Today we do it something like 2, 3, 4 releases a day. We would be happy to get to 50.
50.
50.
50.
50.
Okay.
And in order to get there, we need to do another small but very important paradigm shift. And that's that you basically almost doesn't do any manual QA. In most of our server-side code, we don't do any manual code, but any manual QA, but still we have gates to validate what we're doing, and also because we're still we had a lot of a huge code base that didn't have tests. We started with continuous delivery just a year ago, so we're still struggling to get rid of this legacy code. By the way, we define legacy as code without tests. That's our definition of legacy code.
Yeah.
And we want to improve our ability to deploy and manage the topology of our deployments in an automatic way. I think one of the areas that we're still behind as an industry is we know how to deploy a box. All of the cloud solutions give us the option to create a box, to have an image on it. Things like Chef and Puppet allow us to install software in it. But then to have a service that runs and knows about its peers, might have 3 or 4 instances of the same service, might be connected to a few others, different services that have a number of instances each, might have database, or might be SQL, might be NoSQL, might be Hadoop, might be whatever. It's still a pain in the ass. It's still a problem. And to have a deployment system and monitoring system that is connected together such that everything works, it's still not something, it's not commodity even today. So we're still improving that area in our system. And I think that's an area that we're going to see a lot of improvements in weeks and probably in the industry. Another thing that we're struggling with is storage for large amounts of semi-relational data. And that means if we have basically a document as in terms of a JSON or a XML documents, and you need to store a huge number of those, and that can be a lot of size. That's another challenge, and that's another challenge that we're facing, that we'll have to solve. Today we're using both MySQL as an NoSQL engine. We're using MongoDB, and we're using our own media storage. But we still feel that we need something. We need to recheck what we're doing there. That would be another challenge for us. So I think that's fairly enough.
Sounds enough. Yeah, it sounds like enough challenges for the next 5 or 6 years or whatever.
We have something like, I think, half a year.
Yeah.
6 months.
Fast forward, yeah, exactly.
Yeah.
It's been very interesting. Thanks a lot for sharing all this.
Oh, thank you.
Thanks.